in our setup here, we're looking at two probes, a top push-pull probe and a bottom push-pull probe. You can see down under here. And then we have a platen. This is an aluminum platen that's used, very smooth surface for to put silicon wafers on. Here we have a sample of a silicon wafer here, so we can slide target material underneath the probes. And we're doing a full differential measurement, measure the thickness. Our first step is calibrating the two probes that we have. We have push-pull probes, top and bottom. We have a piece of silicon wafer that has been measured and is 105 microns thick. We're going to slide this in the gap between the two probes. And I'm using this Allen wrench to get it centered in there. All right, so our test sample's centered, and we're going to come over here. All right, we've slid our test sample in, and we're going to show how we calibrate this. We've called up under the measurement tab here, setup channel 1. We click on that. This is the situation we have here, two push-pull probes, and we're going to put our sample thickness in. So this is 105 microns thick. We simply put 105 in there. We click OK. Oh, sorry, calibrate. So we're now calibrated to that sample, 105 microns. So I'm going to click on OK, and we're all set. We're good to go. And we can see up in the window here that our real-time measurement is 105 microns. So we can remove the calibration sample. Next, we're going to measure some of the copper foil samples. All right, we're measuring the copper foil. We've put our first target sheet on the platen here between the two probes. We're looking at the center of the copper. We know it's 18 microns. Here we're reading 19, so it's 1 micron high. We're also running the monitor so you can see the thickness change. I'm going to slide the copper to the 12 o'clock position up near the top of the sample. See what we can see. We're now reading 16. I'm going to go to the 9 o'clock position. We're reading 17. Going to the 6 o'clock position. We're reading 24. Now I'm going to move over to the 3 o'clock position. And we're reading 24. And we're going to slide back to the center. And I see we're crossing some dents, so we're back to the center again, and we're seeing 22. Actually, I'm adjusting it slightly there. Now we're back to what I believe is the center. So, why are we seeing values that are higher than 18? That's because of the dents in the copper causing that. And if we slide around, we can also see these bumps and changes here.